Hey, what's up? Piyush here from MBA 99 Plus Academy, and welcome to yet another lecture on CAT 2024 Crash Course series. Today, we are going to cover a rather very important topic, which is modulus function. Now, many of you requested to present some videos on algebra, so here goes the first one. Modulus function in theory is not a very difficult topic to conquer. However, the questions are seemingly very difficult that may stump you in the examination. So let's just go ahead and cover the theory part first, and then we can go ahead and solve a couple of questions so that you get an understanding of what it is like to solve somewhat difficult questions pertaining to modulus. So here it goes. All right, so concept-wise, it's pretty simple. So let's consider there's a number x. You take a modulus of it. The number will be the value of that function after taking the modulus will be plus x if x is a number which is greater than or equal to 0, and it will be minus x if x is less than 0. Now, let's try to understand this with help of some examples. So, for example, if I take the number plus 2 and I take the modulus of it, since 2 is a number greater than or equal to 0, the modulus of 2 will be plus 2. If I take the number minus 2, the modulus of this number will be minus of minus 2. Now, given that it's a negative number, therefore minus of minus 2 is again plus 2. You can consider it as a sort of some sort of transformer function, that a number which enters the modulus function gives a positive output. Okay, so that's the sort of concept behind the modulus function. Now, let's try to bring in some algebraic concepts or algebraic point of view to this. Let us say there is a number x minus 2 and you are taking a modulus of it. For the number x minus 2, again, look at the theory behind it. For any number x, it will return plus x if that number is greater than 0. So, and the x minus 2 here is a whole entity in itself. So, it will be equal to x minus 2 if x minus 2 is greater than or equal to 0. Which implies if x is greater than or equal to 2, then modulus of x minus 2 will be equal to x minus 2 itself. In the second case, if x is less than 2, the modulus of x minus 2 will be minus of x minus 2, which is equal to 2 minus x. Okay, so that's how we define the modulus function. And once you know and once you are confident about defining a couple of modulus functions, then you are ready to go ahead and solve some problems based on modulus. So let's just go ahead and solve the first question that we have. It was actually a CAT problem, so let's just go ahead and solve it. The question says, if modulus of r minus 6 is equal to 11, okay, and modulus of 2q minus 12 is equal to 8, what is the modulus of the minimum possible value of q by r? Now, it may seem like, whoa, what's up? It seems like there's a lot going on here, but it's actually not. So let's just try to solve this one over here. So the first equation is modulus of r minus 6 is equal to 11. Now, how did we define the modulus function? Modulus of r minus 6 is equal to r minus 6 if r is greater than or equal to 6. We just saw an example above. And it will be equal to 6 minus r if r is less than 6. So we will solve both the scenarios over here and see what results come up. So in the first case, when modulus of r minus 6 is equal to r minus 6, so we will put r minus 6 is equal to 11, which will imply r is equal to 17. In the second case, modulus of r minus 6 is equal to 6 minus r, given that r is less than 6, and that again is equal to 11, which implies r is equal to minus 5. So these are the two possible values of r. It can be either plus 17 or minus 5. Let us solve the second equation. The second equation says modulus of 2q minus 12 is equal to 8. Now again, if 2q minus 12 is greater than or equal to 0, which means if q is greater than or equal to 6, the modulus will open in a positive manner. So in this case, we'll just write 2q minus 12 is equal to 8, which will imply q is equal to 10, right? And in the second case, if q is less than 6,
2 cube minus 12 will open with a minus sign, and that will equal to 8. In this situation, q will be equal to, I will transfer the minus sign over here. So minus 8, 12 minus 8 is 4. 4 divided by 2 is 2. So that's the sort of answer. So q will have two possibilities. Q is equal to 10, q is equal to 2. Now,
for once, just check whatever the values of q and r we have obtained, if they satisfy the condition or not. So the first check over here, we found r is equal to 17, and our assumption was r is greater than or equal to 6. So this is true. R is less than 6. Here we obtain minus 5. True. Q is equal to 10. That's what we obtained, and we postulated that q will be greater than or equal to 6. So that's also true. And the last condition also holds true because we postulated that q is less than 6. And in fact, we found out that q is equal to 2. Mind you, always check. While solving modulus function, always check whatever the solutions you obtain, whether they fit in the condition or not. So it's a mandatory check that you have to make. Now, we have the possible values for r and q. What we have to find is the minimum possible value of q by r and then take the modulus of it. So q by r, what can be the possible values? So for q, there are two possible values, 10 and 2. For every value of q, there is 2 value of r. So there can be 10 and denominator can be 17, or 10 and denominator can be minus 5, sorry. Then q can be 2 and denominator can be 17, and q can be 2 and denominator can be minus 5. We have to find first the minimum of these and then take the modulus of it. Okay, so there are two negative numbers, so the positive numbers cannot be the minimum ones. Of course, 10 upon minus 5 is minus 2. 2 upon minus 5 is minus 0.4. Minus 2 is the minimum among these two. Therefore, the modulus of the minimum value is modulus of minus 2, which will be equal to plus 2. And that's how you solve a problem in, pertaining to modulus. Let us go ahead and solve the second question. This is a rather interesting one because it involves certain sense of handling graphs as well. And that will allow you to solve the question much more faster. So let's just see how to solve this one. The question says, the area of the region satisfying the inequalities modulus of x minus y less than equal to 1, y greater than equal to 0, and y less than equal to 1 is. Alright, let's just take each of them one by one and see whether we are able to draw some sort of graphs or not. The first one, I'm just rearranging this. So I'll write y is greater than or equal to modulus of x minus 1. That's the rearrangement. Give it a thought. Consider only modulus of x. I hope you know what's the graph for modulus of x and how it looks like. So modulus of x is just a v graph. Okay, this is the graph for y equal to modulus of x. Mind you, I'm still not getting into the inequality. I'm just proposing y equal to modulus of x. Now, the question says modulus of x minus 1. So the whole thing will shift 1 unit downwards. I hope you know this concept. So this whole thing, this whole graph will shift 1 unit downward. And let's see how this looks now. So now the graph is modulus of x minus 1. This is minus 1, this is 0. Okay. And we have to find, now still we have not considered the inequality. These lines still represent y equal to modulus of x minus 1. We have to consider y greater than or equal to. So basically we are finding everything above this. So all the shaded region will be our area of consideration. But there are two more constraints. The first one is y is greater than or equal to 0. So we are only considering y values. If this is the y-axis, this is the x-axis, we are considering all the values greater than 0. So upward of this. And y less than equal to 1. So let us say this is the region of 1. And it says y less than or equal to 1. So we are considering values downwards of y equal to 1. So this red shaded area is our area of consideration, and that's what we need to find the area of. And that will be the solution. Clearly, the intersection will be 1 on the x-axis. It will also be 1. Okay. Now, for this line over here, we have y equal to 1. So 1 equal to modulus of x minus 1. So x is equal to 2 and minus 2.
So it will be x equal to -2. There it's x equal to +2. So it's pretty easy now. It's just a trapezium. Okay. So let me just draw it for you over here separately. So it's a trapezium. The base is from -1 to 1. That's 2 units. From -2 to +2. That's 4 units. The height is, of course, 1. So half into height into sum of parallel sides. 4 plus 2 is 6. The area is 3.
You see how simple it is to find the area of the figure using the graphical method. I hope you found this video useful. If you did, please consider liking this video, subscribing to my channel, and don't forget to hit the bell icon as well. Also, in the description box below, I have given the link for the registration to my newsletter. I send it every Friday, and believe me, it will help you be on track as far as your CAT preparation goes. I hope to see you in my next video very soon. Thank you.